Alright, well hopefully they make it to finals.
I thought they competed like last week.
No, they
Well,
competed
last
this
week,
today.
no, he didn't, last week at PO.
They're gonna come back like Thursday.
What was that though?
Maybe.
Like
Come back
that.
Thursday and
That's
then
if
you
they
get
get
Friday.
It's like a separate competition,
If
but they went to it because they were going to compete at the Alamo Dome, so it was like a practice at the place where they were going to compete. You get to you get a feel for the field, get a feel for the stadium. So that way when you go in, you're not freaked out, you've already been there.
That's cool. You're good.
Huh? I don't know.
And then they came rushing back for the game.
They made it back for the game?
Yeah, they did.
Yeah, they made it back.
They still tired.
That's dedication.
We just got there and we performed.
Alright, anyway, so we're gonna continue with the derivative of the inverses, but now we're gonna look at them in a different perspective, a different presentation. So a problem maybe come out like this, where they give you a table with some information, and they ask you to evaluate the derivative of an inverse. Okay, so let's check this out here. So they're asking us for the derivative of the inverse of f at 3. So let's start off by writing the formula there. Okay, what would the formula for that be? Anybody remember? So 1 over f prime of f inverse of 3. It's just 3. Okay, so there's a couple of things we need here. So according to my step process up there, I said I have to equal the original function to the value, right? Okay, so let's do that. What would be the original function? What's the original function if we're doing the inverse of f? F of x, right? But we don't know what the x is. That's what we're actually trying to find. So we're trying to find f of what is equal to 3, which is the y value of that original function. We don't have an actual function to use, so that's why I have to put that. And again, we're trying to solve for the x value, so that's why I left that x part blank there. Do you understand? Okay, so f of what is equal to 3? So now I can go to my table and where do I look? I look at the f, and I find where that is equal to what?
3.
To 3, and I want to know the x that gives me that 3. So what's the x that gives me that 3?
1.
1. Do you understand how I did that? Okay, so that's like finding step 1 and telling me that x equals 1. It's kind of like guessing and checking, and you're finding the answer is 1. Except here we don't have to guess and check. We don't have a function to work with. We just have a table with values on it. Do you understand? All right. Step 2 was to find what? Find the derivative. But I don't have a function to find the derivative of. So can I jump straight to step 3? Which is where I plug that number into my derivative. So I really need to find f prime, because I know that this guy right here is a 1. That's what I just figured out, right? So now I'm ready to find 1 over f prime of 1. So that's what I need to find, f prime of 1. So how can I get f prime of 1? Look at the chart, right? So now do I look for where f prime equals 1? Or do I find f prime of 1? Of 1, right? So I'm putting 1 into that one, and what do I get? I get 2, right? So then the third step would be to get the reciprocal of that, which is 1 over 2, which is exactly what I would get over here if I plugged in 2 into the formula, right? Do you understand? This matches this, because I followed the formula. You don't necessarily have to follow the formula. You can follow those 3 steps that we did earlier. Except here we can skip a step because we don't have a function to get the derivative. Got the idea? Let's try the second one over here. Okay? What would be my function? G of x. Okay, what's the formula for the inverse? Just to write it. 1 over g prime of g inverse of negative 2. Alright, so we need to start off by finding what? Find out where g of what is equal to negative 2. Where do I go to look? What part of the table? G. We kind of need to look at it backwards, okay? Here, Ellie. So we're going to go to G, right? We're not looking for a y, we're looking for the x, right? So we'll go to G and we're gonna figure out where does the y for G equal -2. So when does it equal -2? When x is 1. Yep. So that's the x for the original function, but it's actually the y for the inverse, right? These 2 points would switch. So that tells me that this number in here is actually a 1. So now I need 1 over g prime of 1. So step 2 is to actually do that, g prime of 1. What's the derivative of g at 1? 1. And if I flip that,
Still 1.
it's still 1, right? Because I get 1 over 1, which is 1.
Cool.
Kindergarten stuff? Yeah?
Oh.
Try another one? Now we have some other table. Okay? The first thing they want for you to do is find the derivative of the inverse of g at 1. So let's write down the formula for that one. What is it? How do we get that derivative? 1 over g prime of g inverse of 1. Okay? So in order to get that, I need to start off by finding where the original function is equal to 1. Where does the original function, Sebastian, equal to 1? Go to your table, go to the g function, and find out where does it equal 1. Right there, when x equals 3. That's the number that I need to plug in here. You understand? So now I need to find 1 over g prime of 3. That's where I come over here to step 2 and I find g prime of 3. So Christian, what's g prime of 3? Do I go here and then pick -2? Or do I actually do g prime of 3?
G prime
Of 3, right? And then I figure out that it is -2. So here they were kind of nice, right? If you would have messed up and thought of it the other way, right? You still would have gotten the same answer, right? But it's different, okay? Here we actually know the x, we're finding the y. So what was it? -2, so my steps say to just do what to that? Flip it, so it's -1 over 2, which is exactly what you would get over here. If you were to put -2 there on the bottom, right? Got it? Alright, so then it says, then find the equation of the line tangent to the graph of the inverse when x equals 1. So how do I find the equation of a tangent line? The point and the slope. Alright, so let's start off by finding the point of tangency. So that's going to be 1 comma what? So that means I'm looking for g inverse, right? Of what? Of 1. What's g inverse of 1? Three? 1? Are we lost? There's no reason to be, right? We have a table. So could I make another table for the inverse? So I don't freak out? So go to G and X and do what with the points? Swap them, right? Just so that way you don't panic and don't make a mistake. This will be -2, 1, and this will be 1 and 3. Okay, so if I want G inverse of 1, what's it going to be? 3. Didn't we kind of already get that point over here? If this one was 3, 1, right? Then the inverse should be 1, 3. Right? Cool? Alright, second thing was the slope of the tangent line for that inverse. Do we know that already? Yeah, did we figure it out? Where? Over here, right? When we found the derivative of the inverse at 1, which is the slope of the tangent. Right? This over here is technically my slope of my tangent line. So that is already negative half. So do I have everything I need to write the equation? Alright, so let's do it. So what's the tan line equation? Y minus 3 equals negative half times x minus 1. What's the normal line? Y minus 3 equals 2 x minus 1. So whatever they ask you for, you need to be ready to answer it. Cool? Got it? Too easy? Alright, and the last two examples here. Okay. It says, estimate the value of g prime at negative 1. Based on this value, what conclusion can be reached about the graph of g when x equals negative 1? So are they talking about inverses in this one? No, they just want you to estimate the derivative of g at negative 1. So find the slope of the tangent line at negative 1. So can I do it? What do I need to find the slope of any tangent line? At least 2 points, right? So where is negative 1? Where does that one fall into? Negative 1's right here. So what would be considered good points to use by College Board? So negative 2 and 0, right? Why those two? Because they're right on either side of it, right? Okay, so those are the best ones to pick. And what would be the y values for those x's? 2 and negative 3, right? Because those are points on the graph of g. So if I want g prime, I need to use points on the graph of g, right? If I want g double prime, then I need to use points on the graph of g prime, right? So that would be the graph of the derivative. So be careful, right? Okay, that's the next question. All right, so what do we need here? All we needed was to pick what? 2 points on the graph of g. And what were those 2 points that you picked? Negative 2, comma 2, and the other one was 0, comma negative 3. We can use those 2 points, since they're close to it, actually, to estimate the slope. So g prime at negative 1 is approximately going to be what? Negative 3 minus 2 over 0 minus negative 2, so that becomes plus, so we get negative 5 over. Was that easy? Can you believe that there's questions like this on the AP test that are this simple? And that's like at least 3 points right there for that one question that you cannot get wrong because it's a simple slope question. And some kids do. Cool? Got it? So what conclusion can be reached about the graph of g using that? So we can say g of x is decreasing at x equals what? Negative 1, because g prime of x, the derivative is less than 0. You could write is negative if you want to. But I don't like writing all those words. Cool? So here we're saying that the first derivative is negative. First derivative is describing velocity. Okay, so it's telling me the velocity is negative. So what does it mean when the velocity is negative from your physics experience? Moving backwards? Okay. Okay, what if we're talking about left and right? It's moving to the left, right, because it's negative. But we're talking about vertical motion, it would be moving what?
Down.
Down, okay? So it doesn't mean that it's decreasing, it means that it's going what? Down, right? Ashley? Remember that little thing that we were talking about? Yes? Okay. Alright. Awesome. In calculus, the majority of the motion that we're going to talk about is going to be rectilinear. So it'll be left or right motion most of the time on the AP test. They won't ask you anything about vertical motion. Cool? Alright, we're going to get into that stuff, so I'm really excited about it. Alright, how about this one? What do they want you to estimate here? The second derivative at negative 1. So now I can't use points on the original graph, I have to use points on the previous graph, which would be the first derivatives graph, right? So now it's like I have the first derivative and I want the slope of the tangent line at -1, but the slope of the tangent line on the first derivative graph. Yes? You understand? When we did this one, we had the original graph and I wanted the slope of the tangent line on that one, right? And then I got the derivatives and I made another graph and I want the slope of the tangent lines on that one. Yes? Got it? So here, for this one, I need to pick 2 points again. But they have to be on what? On the first derivative, right? The previous graph to it. So what would be 2 points to use there? We're still going to use -2. And we're still going to use 0 because those are still around -1. But now what are going to be my new y values? 3 and 2, because now we're thinking of them as being points on that particular graph. So this will be a 3 and this will be a 2. And then we just follow the same process. So g double prime at -1 is equal to, or actually approximately, 2 minus 3, right? Over 0 plus 2, -1 over 2. Good? So what does that